Welcome to Easy Physics classes. From today, we are starting a hands-on practice program for Neet. The key to success in competitive exams like Neet lies in practicing previous year's question paper. And that exactly is what we are going to do. This is the first video in this segment from the topic Units and Measurements. So, let us start. The time dependence of a physical quantity P is given by P is equal to P0 exponential minus alpha t square, where alpha is a constant and t is time. The constant alpha, option A, is dimensionless. Option B has dimensions t raised to minus 2. Option C has dimension t square, and option D has dimensions of p.
So here p equal to p0 e raised to minus alpha t square. We have to find the dimension of this physical quantity alpha. Here we are having an exponential term. An exponential term does not have a dimension. That is, this term always represents a number. Similarly, the power of e is always taken as a number. Like this, if 1 is the power of e, then it represents nothing but e. If 2 is the power of e, then it represents e into e. If 3 is the power, then e into e into e. Similarly, alpha t minus alpha t square is also taken as a number. So, dimension of alpha t square will be m raised to 0, l raised to 0, t raised to 0, that is equal to 1. Or dimension of alpha equal to dimension of 1 by t square, that is equal to t raised to minus 2. In terms of mass, length and time, we can write dimension of alpha equal to m raised to 0, l raised to 0, t raised to minus 2.
The joule into S is the unit of option A, energy, option B, momentum, option C, angular momentum, and option D, power.
So here we have to find out which is that quantity that is having the unit joule into second. So first we find out what is joule into second. Joule is kilogram meter square second raised to minus 2. Into second means kilogram meter square second raised to minus 1. That is, joule into second is kilogram meter square second raised to minus 1. Now in the options, first physical quantity given is energy, that is equal to work, and we all know the unit of energy or work is joule. So it is not joule second. Still I am going to find out what will be the unit of energy or work. So we know energy or work equal to force into displacement. In unit it will be kilogram meter per second square into meter, which gives kilogram meter square second raised to minus 2, that is joule. So energy is having a unit joule. Next one, momentum, that is p, mass into velocity. Unit of mass is kilogram and unit of velocity is meter per second in SI system. So that is kilogram meter per second. So momentum is not that physical quantity which is having unit joule into second. Next one, angular momentum. Angular momentum is r p sin theta, where r is the perpendicular distance, p is momentum, then sin theta does not have a unit. So r is having a unit meter in SI system into unit of momentum, that is kilogram meter per second, then that is equal to meter kilogram meter per second. So kilogram meter square second raised to minus 1, which is same as this one, that is joule into second. So angular momentum is that physical quantity which is having unit joule into second. Next, one more quantity is given. Let us check whether that quantity is having the given unit, that is power. Power equal to work divided by time. So we get joule divided by second, but this is joule into second. So this is not that physical quantity which is having unit joule into second. So the answer is angular momentum.
Unit of surface tension in MKS system is option A, dyne per centimeter square, option B, dyne into centimeter, option C, Newton per meter, and option D, Newton per meter square.
Next one, we have to find out what is the unit of surface tension in MKS system. Surface tension equal to force per unit length. The unit of force in MKS system that is equal to kilogram meter per second square or Newton divided by unit of length is meter. So the answer is Newton per meter.
Indicate which pair of physical quantities given below has not the same units and dimensions. Option A, momentum and impulse. Option B, torque and angular momentum. Option C, acceleration and gravitational field strength. And option D, pressure and modulus of elasticity.
First one, momentum and impulse. Impulse is nothing but change in momentum. So the unit of impulse and momentum will be equal, and that is equal to kilogram meter per second, because the formula for momentum is mass into velocity. Mass into meter per second is the unit of velocity. Writing dimension, it will be mLt raised to minus 1. M represents mass, Lt raised to minus 1 for velocity. Next one is torque and angular momentum. We know that torque is the rate of change of angular momentum. So of course the unit of these two will not be equal. Still I am going to find out what is the unit of torque and what is the unit of angular momentum. Torque equal to Rf sin theta. It is here kilogram meter per second square is force, unit of force in SI system, into m, that is unit of R. So kilogram meter square per second square. Next one is angular momentum, that is from here we get angular momentum dl equal to or L equal to tau dt. So tau dt will be unit of tau is kilogram meter square per second square into t, that is s, which is equal to kilogram meter square per second. So these two units are not equal, so their dimension will not be equal. Next one is acceleration and gravitational field strength. Gravitational field strength means gravitational field intensity. Acceleration is having a unit meter per second square. Gravitational field strength can be written as G capital M by R square. That is, we have to find out unit of G, unit of mass, all divided by unit of distance square. This is also same for the case of small g, because the formula for small g is Gm by capital R square. So while writing unit of small g, you have to find the unit of g into unit of mass, all divided by unit of distance square. That is, unit of E and unit of g are same. Here g is acceleration due to gravity. That is, unit of E is equal to unit of acceleration, and which is equal to meter per second square. So both are having same units. Okay, listen here, pressure and modulus of velocity. Modulus of velocity is equal to stress by strain. Now here unit of stress is same as that of unit of pressure. Pressure equal to force acting normal to the surface by area, and stress is force by area. That is, dimensional formula of pressure equal to dimensional formula for stress, because both are force by area while considering dimensions. That is equal to ml t raised to minus 2, that is the dimension of force, divided by dimension of area, that is L square. So we get ml raised to minus 1 t raised to minus 2. So both are having the same dimensional formula. So modulus of velocity equal to unit of pressure divided by strain, but strain does not have a unit. Then unit of modulus of velocity will be equal to unit of pressure itself, because strain does not have a unit. Therefore pressure and modulus of velocity are having same unit and dimensions. If unit is same, dimension will be also same. And the given options, torque and angular momentum are the physical quantities which does not have the same unit and dimensions.
Planck constant has the dimensions of option A, energy, option B, momentum, option C, frequency, and option D, angular momentum.
So here we have to find out which is that physical quantity that is having same unit as that of Planck's constant. We know the equation lambda equal to h by p. Lambda is the wavelength associated with matter. So from this equation we get the h equal to lambda p, and lambda is the wavelength, then the SI unit will be meter, then unit of p is kilogram meter per second, then we get kilogram meter square per second, which can be written as kilogram meter square per second square into second. Here kilogram meter square per second square is joule, joule into second. So joule into second is the unit of angular momentum. So Planck's constant is having the unit of angular momentum. So the dimension of Planck's constant is same as that of angular momentum.
9 second stands for the unit of option A force, option B work, option C momentum, and option D angular momentum.
Here we have to find out the physical quantity that is having unit dyne second. So dyne is the CGS unit of force into time. Second is the unit of time. So this is CGS system. You are familiar with this thing, that is F into dt, that is force into time, that is impulse. Impulse is change in momentum. In the option they have given force, work, momentum and angular momentum. So no impulse is there. So the physical quantity associated with dyne second is momentum. So dyne second is the unit of momentum in CGS system.
The dimensional formula for coefficient of thermal conductivity is option A mLTK, option B mLt raised to minus 2, option C mLt k raised to minus 1, and option D mL t raised to minus 3 k raised to minus 1.
Okay, here we have to find out the dimensional formula for coefficient of thermal conductivity or thermal conductivity K. Now by law of conduction we have a rate of heat flow dq by dt equal to minus Ka d theta by dt, where K is the thermal conductivity, A is the area, d theta is the temperature change, dx is the distance, dq is change in heat energy, dt is time taken. Now from this equation we get dimensional formula for K equal to, taking all the term to the left side, we get dimensional formula dq into dimensional formula of dx all divided by dimensional formula of d theta into dimensional formula of dt into dimensional formula of area. Now dq is heat, so it is energy. Dimension of energy is ml square t raised to minus 2 into dx, that is distance, so L divided by dimension of temperature, that is K, into time into area, that is L square. So we get solving, we get ml t raised to minus 3 k raised to minus 1. That is the dimension formula for thermal conductivity K.
The unit of Stefan's constant sigma is option A watt raised to 4 divided by m k raised to 4, option B calorie divided by m square k raised to 4, option C watt divided by m square k raised to 4, and option D joule divided by m square k raised to 4.
Here we have to find out the unit of Stefan's constant sigma. The radiant energy emitted by a perfect black body per unit area per second is sigma T raised to 4. T is the absolute temperature, sigma is the Stefan's constant. R is the radiant energy emitted per unit area per second. So from this formula we get unit of sigma equal to unit of R into unit of T raised to minus 4. So unit of R is energy emitted per unit area per second, that is energy, that is joule, per unit area means meter raised to minus 2, per second means second raised to minus 1, into the unit of temperature, that is Kelvin raised to minus 4. Then joule per second is watt, so joule per second is watt, meter raised to minus 2, Kelvin raised to minus 4. So the answer is watt divided by meter square, Kelvin raised to 4.
The dimensions of half epsilon 0 E square, where epsilon 0 is permittivity of free space and E is electric field, are option A ml t raised to minus 1, option B ml square t raised to minus 3, option C ml raised to minus 1 t raised to minus 2, and option D ml square t raised to minus 1.
Okay, next one we have to find out the dimension formula, dimension of half epsilon 0 E square. Half epsilon 0 E square is nothing but energy density that we have learned in 12th class, and the topic is associated with energy density of a capacitor. That is, energy density is nothing but energy per volume. Now the dimension of energy is ml square t raised to minus 2 divided by volume is L cube. So we get ml raised to minus 1 t raised to minus 2. That is the dimensional formula of half epsilon 0 E square.
If C and R denote capacitance and resistance, then the dimension of CR is option A m raised to 0 L raised to 0 t, option B m L raised to 0 t, option C m raised to 0 L raised to 0 t square, option D not expressible in terms of m, L and t.
In this case we have to find out the dimensional formula for C into R, where C is the capacitance and R is the resistance. Before that I am going to find out what is the dimension of C, capacitance. Capacitance equal to Q by V, that is dimensional formula for capacitance equal to dimension of Q by dimension of V. Then Q by V is work done per charge, this Q will go to the numerator, then Q square by W. Now the dimension of Q is AT, so A square T square divided by work is ml square t raised to minus 2. So we get m raised to minus 1, L raised to minus 2, t raised to 4 A square. Then dimension of R equal to V by I. V is nothing but work by charge divided by I is Q by T. So simplifying we get work into time divided by Q square, that is equal to ml square t raised to minus 2, that is work into t. So t raised to minus 2 becomes t raised to minus 1 divided by a square t square. So we get ml square t raised to minus 3 a raised to minus 2. Therefore the dimension of CR will be, this is the dimension of C and this is the dimension of R. Here m raised to minus 1 and m will cancel, L raised to minus 2 L square will cancel, t raised to 4 and t raised to minus 3. So this becomes t, a square and a raised to minus 2 will cancel. So dimension of CR is equal to dimension of t, dimension of time. Writing in terms of mass, length and time, we get dimension of CR is m raised to 0 L raised to 0 t to the power 1.
The dimensions of mu 0 epsilon 0 the whole raised to minus 1 by 2 are option A L raised to minus 1 t, option B L t raised to minus 1, option C L raised to minus 1 by 2 t raised to 1 by 2, option D L raised to 1 by 2 t raised to minus 1 by 2.
So here we have to find out the dimension of mu 0 epsilon 0 all raised to minus half, which can be written as 1 divided by root of mu 0 epsilon 0, which is nothing but c, that is speed of light in vacuum, which we have learned in the chapter electromagnetic waves. So dimension of mu 0 epsilon 0 all raised to minus half is equal to dimension of c, that is speed of light. While you are writing dimension, we only consider which is the physical quantity. Here the physical quantity is speed. So speed is having dimension Lt raised to minus 1. So the dimension of mu 0 epsilon 0 all raised to minus half is Lt raised to minus 1.
The relation P is equal to alpha by beta e raised to minus alpha z divided by k theta, where P is pressure, z is distance, k is Boltzmann constant and theta is temperature. The dimensional formula of beta will be option A m raised to 0 L raised to 2 t raised to 0, option B ml square t, option C ml raised to 0 t raised to minus 1, and option D m raised to 0 L square t raised to minus 1.
Here we have to find out the dimension of beta. P pressure, that is distance, k Boltzmann constant, theta temperature. What is alpha? It is not given. And we have to find out the dimension of beta. In this problem we are having exponential here. We discussed this type of problem earlier. e raised to minus alpha z by k theta is simply a number. So dimension of p, because this is exponential, so dimension of p is equal to dimension of alpha by beta, or dimension of beta will be equal to dimension of alpha by dimension of p, that is dimension of alpha into dimension of p raised to minus 1. But to get the dimension of beta, we have to find out what is the dimension of alpha. For that, I am taking this part. We all know that this is simply a number. So that means, and the power shows how many times we have to multiply e. That is alpha z by k theta is also a number. So the dimension of alpha z by k theta is nothing but m raised to 0, l raised to 0, t raised to 0, which is equal to 1. That is dimension of alpha z equal to dimension of k theta, or dimension of alpha equal to k theta by z. Here k is Boltzmann constant, dimension of Boltzmann constant, ml square t raised to minus 2, k raised to minus 1. Theta is temperature, so Kelvin, divided by z is distance, so L. So get ml t raised to minus 2 as the dimension of alpha. That is, we get dimension of beta equal to dimension of alpha into dimension of p to the power minus 1. We got dimension of alpha as ml t raised to minus 2 into dimension of p, that is ml raised to minus 1, t raised to minus 2. This minus 1 is here. Then solving, m and m raised to minus 1 will cancel. L raised to minus 1 to the power minus 1 will be L raised to 1. So L into L will give L square, t raised to minus 2 and t raised to plus 2, because minus 2 into minus 1, t raised to minus 2 will cancel with this term, t raised to minus 2 all raised to minus 1 will become t raised to plus 2. So these two terms will cancel. Then we get L square, dimension of beta as L square. Now in terms of mass, length and time, dimension of beta can be written as m raised to 0, L square, t raised to 0. So that is the answer.
The dimensions of resistance are same as those of dash, where h is the Planck's constant and E is the charge. Option A, h square divided by E square. Option B, h square divided by E. Option C, h divided by E square, and option D, h divided by E.
So here we have to find the dimension of R. Dimension of R is dimension of V by I. V is work done by charge. Then work is having dimension ml square t raised to minus 2. Charge is 80 into IA. So we get ml square t raised to minus 3, A raised to minus 2. Now I am going to find out what is the dimension of h by E square. Here h is Planck's constant. Already we have discussed this thing, that is dimension of Planck's constant is equal to dimension of angular momentum. So dimension of angular momentum and dimension of Planck's constant are same only in terms of dimension. Then physically they are different. So angular momentum divided by E square, that is equal to ml square t raised to minus 1, that is the dimension of angular momentum, divided by a square t square. It is the dimension of charge, so a square t square, because the square of charge is here. Then which is equal to m l square t raised to minus 3, a raised to minus 2, which is same as that of dimension of resistance.
The speed v of ripples on the surface of water depends on surface tension sigma, density rho, and wavelength lambda. The square of speed v is proportional to option A, sigma by rho lambda, option B, rho by sigma lambda, option C, lambda by sigma rho, and option D, rho lambda sigma.
Here it is given that speed v depends on surface tension sigma, density rho, and wavelength lambda. So we are going to write v proportional to, because we don't know how it depends, what will be the powers of sigma, density and wavelength. We are going to write power of sigma as A, power of density as B, power of lambda as C. We don't know what are the values of A, B, C. So V proportional to sigma raised to A, rho raised to B and lambda raised to C. Now writing the dimension on both sides, we get this is speed, so m raised to 0 Lt raised to minus 1. Here on the right side we get surface tension is force per unit length, that is force divided by length, that is mlt raised to minus 2 divided by L, LL will cancel, L and L will cancel, so we get mt raised to minus 2 to the power A. Then this is density mass by volume, so ml raised to minus 3 to the power B. Then lambda is wavelength, length means L, so L raised to C. Then we get m to the power A, here there is a power A for m, then again into m raised to B, so we get m raised to A plus B. For L, here minus 3b is there as power, here C is there as power, so L raised to minus 3b into L raised to C, then it becomes L raised to minus 3b plus C, T raised to minus 2a. Now by the principle of homogeneity of dimension, we know that the dimension on each term on either side of the equation will be same. So by we are going to apply the principle of homogeneity of dimension here. It states that the dimension of each term on either side of the equation will be same. That means dimension of this term and dimension of on the right side must be same. There will be a constant when we make this as an equation, but here no need to write in form of equation, so I am just writing like this. So dimension of V and dimension of this term must be same. So I am going to equate the powers of m, l and t on both sides. We get here the power of m is 0, on the right side it is a plus b. Since these two are same, a plus b equal to 0 or a equal to minus b. From here we get minus 3b plus c, on the left side it is 1. So minus 3b plus c equal to 1. Leave this part here. Next we are going to this term, here it is minus 2a and the left side it is minus 1. So minus 2a equal to minus 1 or a equal to 1 by 2. So substituting the value of a equal to 1 by 2 in this equation, that is we get from here we get b equal to minus a. So b equal to minus a, that is value of a is half, so b equal to minus half. Now substitute the value of b equal to minus half in this equation, we get minus 3 into minus 1 by 2 plus c equal to 1 or c equal to 1 minus 3 by 2, which is equal to minus half. Substituting the values of a, b and c in this equation, we get v proportional to sigma raised to half, rho raised to minus half, lambda raised to minus half. That is, here in this question they have asked us to find out square of speed. Square of speed will be proportional to sigma rho raised to minus 1, lambda raised to minus 1. That is proportional to sigma divided by rho lambda. That is, square of speed is proportional to sigma divided by rho lambda.
Pascal second has the dimension of option A, force, option B, energy, option C, pressure, and option D, coefficient of viscosity.
So here we have to find out from the given for physical quantity, which physical quantity is having the dimension, having the same dimension as that of Pascal second. Pascal is the unit of pressure, second is the unit of time. So Pascal second is pressure into time. Dimension of pressure is ml raised to minus 1 t raised to minus 2 into time, which is equal to ml raised to minus 1 t raised to minus 1. So that is the dimension of Pascal second. Now dimension of force is mlt raised to minus 2. Dimension of energy, that is force into displacement. So mlt raised to minus 2 into L. So ml square t raised to minus 2. Dimension of pressure, that is force by area, mlt raised to minus 2 divided by L square. So we get ml raised to minus 1 t raised to minus 2. So the dimension of these three are not equal to the dimension of Pascal second. So the last one, that is coefficient of viscosity. We know the viscous force between the layers of liquid can be found out from the formula F equal to eta A dV by dr. From that formula, coefficient of viscosity eta equal to F by A into dV by dr. Dimension of F is mLt raised to minus 2, area L square, dV in dimension it is velocity. So Lt raised to minus 1 divided by dr, that is distance. So L will cancel here, L and L square. So we get L raised to minus 1 on the numerator, then t raised to minus 2 and t raised to minus 1. So we get t raised to minus 1 on the numerator. So we get m L raised to minus 1 t raised to minus 1, which is equal to the dimension of Pascal second.
Thank you for watching. Please subscribe our channel for more updates.